Hi, good morning, good afternoon, good evening, wherever you're listening the video from. My name is Ashwat. I work as a principal engineer at Razorpay. I also have Ankit and Mani with me, who also work with me in the Razorpay security team. So today we are here to talk about Arctic. So this is a tool that we built internally, which is a wrapper around the threat intel platform MISP that we use. And also the other piece is it's kind of customized to the cloud native platforms, which most startups or most enterprises these days use. Let's move quickly into why we did this and how we started the whole journey, right? So while we were trying to get into threat intel, we were trying to uh, we created a wish list first of all before we kind of narrowed down on the tooling. So the first piece is we wanted coverage across all of the Razorpay environment. What exactly does this mean? I'll talk about it in a later slide. And we wanted it catered to the fintech industry. That is, if you take any threat intel feed, it has like a lot of alerts coming in, and some of them are not relevant to the environment, and some of them are super generic, right? So we wanted something very specific to the fintech industry, and also there are a lot of false positives, like you might have seen. So we wanted to kind of cut down on the false positives. So this is like another angle that we introduced. And finally, like automated remediation, right? So that's where we used a tool called Shoreline, and we also have Charles, who's the co-founder and CTO of Shoreline, here on the call. So Razorpay's environment, talking about the infrastructure. So we are completely cloud native, completely on AWS, and we have a few bits and pieces on other cloud environments, but mostly on AWS. And we are mostly on EKS, all on Kubernetes. For runtime, we have Falco running to provide us like runtime alerts. And most of the endpoints that developers use are all Macs. For document and identity, we use Google Workspace. So it's like Google Docs, Google Sheets, and so on. And for identity, we use Azure Active Directory. So moving on to the right side, for other tooling, we use like a lot of SaaS. Prominently, we use like GitHub, Jira, Shoreline, and a couple of other tools. So custom requirements that we had, right? So Razorpay is a payment gateway where we process over $1 billion over a year, and we have 10 million plus merchants, right? So for every merchant, we give them a specific key, which is like a merchant key and a secret. And sometimes merchants might just go check this particular keys into GitHub, or they might hard code it in APKs and so on, right? So if these particular keys get in the hands of attackers, then it's a problem where they might be able to take over the account of a merchant, or they might be able to do malicious things with the merchant's account, right? So, and also we wanted to look at fintech specific threats and brand monitoring, and also like some of the employee compromise machine, right? So here for each of these scenarios, we use a different tool. I'll talk about it in the next few slides. So while we were narrowing down on the tooling, we had an option of a build versus buy. So we said, if we buy a solution, then it would take a lot of time to customize the solution. So MISP was a great platform. It had all of the frameworks in place, and it had most of the base or the core of the threat intel platform in place. And the great part about MISP is it has very good integration support, where you can bring in your own tools, kind of feed it into the system. So that's where it becomes really useful. And also by default, MISP itself comes in with a lot of open source threat intel feeds. So these are like free feeds that come in. But while MISP was great, the shortcomings were so most of the feeds that it provides are in terms of IP addresses, URLs, domains, right? So if you think about this, the IP addresses can be easily changed by attackers, and also so the domain names, right? So that's where it becomes a little bit tricky. And also there's no history or correlation to go back and say, hey, I saw this particular attack a month ago or 2 months ago. So that's where the other problem is. And the last piece is customized priority, right? So let's say I put all of the feeds together and my old history together. Can I provide like my own priority? For example, let's say if I have seen this particular attack and I've triaged this particular attack, and they caused a lot of damage, and 3 months later the same attacker comes in, then I want to give it a higher priority or like a critical priority, so that I can go action on this particular feed very quickly, right? So introducing Arctic. So this is what we built over the MISP platform. So just at a high level architecture, right? So on the top, we deployed MISP on Kubernetes, and the database was on RDS, and we also had the meat-ray feeds coming in, right? So and the notification part, which is towards the right side. So we use Jira and Slack. And for critical remediations, we took the feed, we took the alerting from here, and then we used Shoreline to go do some of the remediation. So Ankit will talk about a very cool scenario where we had like a lot of attacker traffic coming in, and how did we remediate against that, and so on. So then looking, the centered box here is more around our endpoints. So we had AWS and EKS sending in a lot of alerts. So specifically from AWS, we had CloudTrail, Guard Duty, and so on. From EKS, we had Falco. And from endpoints, we had Cortex alerts coming in. And from Azure Active Directory, we had all of the logs feeding in, and similarly with Google Workspace, right? So in the bottom left, we see the logging platform, that is SumoLogic, that we were using in the past, and also the custom data lake. But the right half on the third row is the interesting piece, right? So FSISAC is very customized to the fintech industry, and they provide a lot of high fidelity feeds which have very low false positives. And this is what some of the other banks and the fintechs have really seen in their environment. So that's where it is super handy. And the second part is, second box there is about the government and the regulatory feeds. So especially in India, the RBI and NPCI, they keep sending us alerts saying, hey, we've gotten threat intel that this particular IP address is bad, this particular IP address is trying to do a phishing attack, and so on, right? So we ingest those feeds as well. Then the third part is with respect to CloudSec. So this is where this is a cyber intel platform and a brand monitoring platform. So anytime they see an attack, they let us know. And the last piece is PingSafe. So PingSafe is a CNAP, but they have also provided us a functionality where they go look for leaked secrets, specifically like merchant keys with respect to Razorpay on GitHub, Pastebin, and like a bunch of other locations where this might get leaked, right? So that said, here is kind of the base architecture or the starting point on where we had to go, and what we did with it and how we built Arctic is what Ankit will focus on. Over to you, Ankit.
Yeah, thank you, Ashwath. So let me first of all again go back to the wish list which Ashwath talked about. This is what we had in mind when we started building Arctic. So in terms of coverage, at base MISP, you may know that we have coverage in terms of IP, email, domain, but what we wanted out of Arctic is to also cover for all of Razorpay infra components, which includes Google Workspace, Azure, AWS, Gates, etc. And the second point, which was important for us, was the feeds needed to be fintech specific. At base MISP, you have, since the feeds are open and free, so it comes from all across the place. So in Arctic, we wanted to have it specifically around fintech. We achieved this using some paid feeds as well, like for example, FSISAC and CloudSec, which is another threat intel monitoring platform. And then we tagged it along with the free feeds that we already were receiving from the base MISP. On top of these two, we also built our own internal feed, which is part of the demo. We'll show you how we did that. The third major point, and perhaps the biggest Achilles heel for the base MISP, was the false positive. So this was definitely our wish list, that we wanted the false positive at the most minimum possible, and it is not achievable by the base list. The reason being that it correlates with all the free feeds or all the feeds that we have enabled, and it has a lot of false positive. Anybody who has run the base MISP knows that there is a lot of false positive that comes with the feeds that MISP gives us. So to counter that, we had our own internal feed built in, which kind of did a correlation with the base MISP feed. And then on top of it, we had our own proprietary algorithm, which gives us a severity score of its own. The severity score helps us to identify whether the feed that is coming belongs to a true positive or a false positive. So it greatly helps us to reduce the total number of false positives coming out of MISP. And the final piece was, once we have everything together at one place, we wanted also to have an auto remediation feature. This feature does not come with the base MISP at all. So this is where we leverage Shoreline. There are two important use cases or two important flexibilities that Shoreline provides. I'll just go through them in the next slide. Ashok, can you change the slide? Yeah. So what Shoreline helps us do or achieve with Arctic here is, when we do remediation, there are two scenarios that can arise. One is, once we have the score, the threshold mapping, we would want the alerts to be immediately logged without any manual intervention, or else there may be scenarios where we are somewhat confident about the malicious or the reputation of the IOC, but we would still want a manual check to be introduced. So both of these use cases are captured pretty well by Shoreline. The place where we want to have critical alerts directly auto remediated, we can do it directly through a Shoreline notebook. And even when we want to introduce a layer of manual analysis, we can still do that with the same notebook. And the only change is that we literally just have to click a button and the remediation still takes place. So in the next slides, we will talk about the demo of the tool Arctic. And before I pass over to Mani to take the demo, I'll just kind of give a very brief summary of what are we going to see in the demo. So we've tried to cover two use cases here. One is a true positive, where we capture the internal feed, we map it with the feeds that are coming from the paid and the free feeds at MISP. We give them a score, and then we will see that since the score is pretty high, higher than what our threshold is set, as a result of which a ticket is created for that particular IOC. Then we'll also see a scenario, which is a false positive, where we'll see that the internal feed captures an IOC or an IP, but since the threshold score for that particular IOC is not greater than what we have set, or basically the score that comes out of that IOC is not greater than our threshold, it does not create a ticket. So essentially, that takes care of our important wish list of minimizing the false positives. And the final piece of this demo is to show the remediation that happens through Shoreline. So I'll just ask Mani now to take you through the demo. Mani, over to you.
Thanks, Ankit. So this video will take you through three different scenarios. One with the collected IOCs from the Arctic, and how it is taking, okay, this is the true positive, and go into the next stages for the remediation. And the next scenario will be how the false positives are handled here. And the final piece will be how the remediation is handled. So this will start with the demo. So Arctic is like a wraparound base MISP. So this will comes along with the base MISP. So the Arctic will also have the same thing, but along with it, we have some private feeds like FSI, CloudSec, and Razorpay. Razorpay is very specific to Razorpay, which we created as a feed. And most of the logs are coming from Sumo, landed on Sumo Logic, and we collected that and do the IP reputation. And then it is pushing back to the S3 for the automation, which Arctic will take care of it. So it will read all the data and it will match with the high confidence. High confidence in the sense, this is a separate category which we feel, okay, these are the high severity and the high confidence data. And if it matches the threshold with the collected IOC, then we will say that, okay, this will be the true positive. So this is a simple scenario, like on a particular day, these are the IPs are collected, and it is coming from the high confidence. And if you go to check with the Arctic tool, that IP will be matched with the different sources. So in this case, it is matched with the FSI SAC, and the downside, if you see, it will be matched with the Razorpay feeds also. So like this, the multiple feeds, multiple sources can be matched, and that is how the correlation is happening. And once you get this confirmation and the threshold is reached, then it will basically going to the Jira to create a ticket with all this information, the contextual information, so the analyst can take a serious action. So the second scenario will be on the other day, you get this same kind of a data on the high confidence thing, but this doesn't match with the severity, match with the threshold level, and then this will be not taken into true positive, and the Jira ticket will not get created. So this is how the false positives are handled here. And we check that particular IP on the second scenario, you didn't find any Jira ticket. So the last piece will be the auto remediation piece. So that is just clicking the button on the postman. So the collected IP from the Arctic will make a call to the postman. Postman will be adding the IP to the IP set. So just clicking the button, collected the IP, it will land it to Shoreline. Shoreline will take that IP and add it to the IP set. So here you can do whatever you want, add that IP to the egress layer like security group, and then you can control where it is getting communicated, and you can do whatever you want. Yeah, that's all. Thank you.